The United States Mint produces millions of coins every single day. Among them are one of the most familiar pieces of money in America, the 25-cent coin. But have you ever stopped to wonder how these small pieces of metal are actually made? How does a completely flat sheet of metal become a coin with incredibly detailed designs, perfectly formed edges, and a precise weight and diameter? And how can a factory produce hundreds of thousands of identical coins while making sure that every single one meets strict specifications? To find out, we are going inside one of the most secure manufacturing environments in the world. This is where enormous rolls of metal are transformed into something that will eventually pass through the hands of millions of people. And the process is far more impressive than it might seem. Because before a quarter becomes money, it starts as a simple sheet of metal. Everything begins with enormous rolls of copper-plated nickel sheet. These are not small pieces of material. A single roll can contain almost 1.5 feet of metal, roughly the length of 4 football fields. And each roll weighs several tons. The material is carefully engineered to withstand years of constant use. A coin might be dropped on the ground, carried in a pocket with keys, thrown into a machine, exposed to moisture, or handled thousands of times. So the metal has to be strong enough to survive all of it. For quarters, the material is made primarily from copper with a nickel component, creating a combination designed to provide the durability required for everyday circulation. But before any of that metal can become a coin, it has to be transformed into thousands of individual pieces. And that is where the production line begins. The enormous rolls are transported into the manufacturing area and positioned on specialized equipment. A powerful machine begins unwinding the metal with extraordinary precision. The sheet moves forward continuously, feeding directly into one of the most impressive machines in the entire factory, a massive blanking press. And this is where the first transformation happens. The principle is surprisingly simple. Imagine a giant cookie cutter. Instead of cutting dough, however, this machine is cutting metal. With every movement, the press punches perfectly circular discs from the sheet. These discs are called blanks. Each one is already extremely close to the final dimensions of a quarter. But at this point, they are still completely anonymous. There is no portrait, no eagle, no inscriptions, no denomination, just thousands of small metal discs. The press works incredibly quickly. Every stroke lasts only a fraction of a second, allowing enormous quantities of blanks to be produced in a very short period of time. A single roll can generate hundreds of thousands of these discs. But there's an interesting problem. When you cut circles from a sheet, you can't use every square inch of material. There are always gaps between the circles, and those gaps create a strange-looking metal skeleton. This leftover structure is known as webbing. It almost looks like the remains of a giant sheet of metal that has been eaten away by a machine. But this material isn't simply thrown away. Instead, an automated system immediately separates the leftover metal from the blanks. The scrap is collected and sent for recycling. It can then be melted down and transformed into new metal sheets. That means the manufacturing process can recover a huge amount of the material that would otherwise become waste. And this is important because we are talking about millions of coins. Even a tiny amount of waste per coin would eventually add up to an enormous quantity of metal. So the factory is designed around a simple principle: as little material as possible should be lost. As the blanks leave the enormous punching press, something almost surreal happens. Thousands of small metal discs begin pouring out of the machine. They fall into collection systems in a cascade that looks almost like a metallic waterfall. For a moment, it could almost look like the factory is producing money. But technically, it isn't. Not yet. These pieces have the approximate size and shape of a quarter, but they have absolutely no design. They're simply pieces of metal. They cannot be used to buy anything. They don't have a face value, and they aren't officially recognizable as coins. Before that can happen, the metal has to undergo several critical treatments, and one of the most important comes next. The blanks are about to be exposed to extreme heat. The freshly made blanks are transported toward a huge annealing furnace. Inside, temperatures can reach approximately 870 degrees Celsius. That's hot enough to make the metal glow intensely. But this isn't simply about heating the discs. Something much more important is happening inside the material. During the punching process, enormous mechanical forces are applied to the metal. That creates internal stresses and changes the material's structure. If those stresses were left untreated, the blanks could become too hard or brittle for the next stages of manufacturing. They could crack, they could deform, or they could fail when subjected to the enormous forces of the final striking process. So the blanks are heated under carefully controlled conditions. The furnace atmosphere is controlled to limit the presence of oxygen and reduce oxidation while the metal is being heated. At the microscopic level, this treatment changes the internal structure of the metal. The stresses created during blanking are relieved. The material becomes more workable again, and this gives the blanks the flexibility they need for the next stages of their transformation. After spending time inside the furnace, the discs emerge extremely hot. Their temperature is so high that direct contact would cause severe burns almost instantly, so the process cannot simply stop there. The blanks have to be cooled and cleaned. And that is where chemistry enters the production line. The glowing blanks are moved into a specially controlled cleaning process. At first glance, the liquid might look almost like ordinary water, but it is not. The bath contains water, citric acid, and other carefully controlled compounds. Citric acid is naturally found in fruits such as lemons and oranges. Here, however, it is being used for a much more industrial purpose. It helps remove oxidation and unwanted material from the surface of the blanks. The goal is to leave the metal clean and ready for the next transformation. This stage might seem relatively simple compared with the enormous presses and furnaces, but it is critical. The surface of every blank needs to be properly prepared before it can receive the detailed design of the finished coin. Any contamination or unwanted residue could interfere with later stages. Once the blanks have been cleaned and dried, they move toward another machine that performs a surprisingly important job. And this machine is responsible for creating something you probably never think about when holding a quarter: its edge. The machine is known as a rimming or upsetting machine. Its job is to transform the flat blank into a piece of metal that is ready for the enormous pressure of the striking process. The blank passes through a precisely engineered channel formed between hardened steel components. The channel is only slightly narrower than the diameter of the blank. As the disc is forced through the opening, the metal around its perimeter is compressed. At the same time, material is displaced upward. The result is the raised rim that surrounds the coin, and it happens incredibly quickly. At normal speed, the process is almost impossible to see. But when the machinery is slowed down, the transformation becomes fascinating. A completely flat disc enters the machine and emerges with the characteristic raised edge of a coin. That tiny rim is not just decorative. It serves several important functions. It gives the coin additional rigidity. It helps protect the design from excessive wear. It allows coins to stack more consistently. And perhaps most importantly, it helps control how the metal behaves when the coin is struck. Without the properly formed rim, the metal could spread outward under the enormous pressure of the coining process. The result could be a distorted or unusable coin. So before the design is even added, the edge has to be perfect. Now the blanks are finally ready for the most spectacular stage of the entire process, the moment when they become recognizable as coins. At this point, everything has been leading toward one machine, the coining press. The blanks already have the correct dimensions. Their surfaces have been cleaned. Their edges have been formed, but they are still just metal discs. Now they need an identity. Inside the coining press are hardened steel dies engraved with the designs that will appear on the finished coin. One die carries the design for one side. The other carries the design for the opposite side. The blank is positioned between them. And then the machine strikes. The force is enormous. The pressure can reach around 100 metric tons. All of that force is concentrated into an incredibly small area and applied in a fraction of a second. The metal does not simply get stamped like a piece of paper. It actually flows under pressure. The material is forced into the microscopic cavities of the dies. And suddenly, details that were completely absent a moment earlier begin to appear. The portrait, the lettering, the denomination, the intricate details of the design. The coin has finally become recognizable. What was previously nothing more than a small metal disc is now a quarter. And the speed is almost as impressive as the force. A modern coining press can strike approximately 750 quarters every minute. That's around 45 coins every hour. And over the course of a full working day, a single press can produce hundreds of thousands of finished coins. Think about that for a moment. Every one of those coins needs to have the correct dimensions. The correct weight, the correct design, the correct edge, and the correct appearance. And that's where the factory's next challenge begins. Because producing a coin is one thing, producing millions of identical coins to extremely strict specifications is something else entirely. As the newly struck quarters leave the press, they enter one of the most important stages of the entire process: quality control. The coins may look perfect to the naked eye, but manufacturing defects aren't always obvious. That's why inspectors and automated systems examine samples from the production line. They check the designs, they examine the details of the strike, they verify the alignment between the front and back. They look for damage, deformation, or imperfections. Even a relatively small deviation can trigger an investigation. If a sample indicates a problem, the corresponding batch can be held for additional inspection. The reason is simple. Once a defective coin enters circulation, it becomes much harder to control. The entire philosophy of the process is therefore based on preventing defective coins from leaving the facility in the first place. And what happens to the coins that fail inspection? They aren't simply thrown into the trash. The metal can be recovered. It can be processed again and eventually returned to the manufacturing cycle. Once again, very little material needs to be wasted. This is especially important when you're producing millions of coins. A tiny defect repeated thousands or millions of times could represent a huge amount of lost material. So quality control isn't just about protecting the reputation of the mint. It's also about protecting the efficiency of the entire manufacturing system. Once the coins have passed inspection, they're finally ready to leave the production line. But there is still one problem. How do you count hundreds of thousands of individual coins? Obviously, nobody is going to count them one by one. Instead, enormous automated counting systems take over. The quarters are transported through machines capable of sorting and counting them at extremely high speeds. Eventually, the coins are directed into large industrial bags. One bag can contain 200 quarters, and because every quarter is worth 25 cents, that's exactly $50. But there's a catch. $50 in quarters is extremely heavy. Each bag weighs several tons. So these aren't bags that workers can simply pick up and carry away. They have to be moved using industrial equipment such as forklifts. The filled bags are then transported into secure storage areas, and this is where the journey inside the factory finally comes to an end. But the journey of the coins is only beginning. The finished bags remain inside highly secure facilities until new shipments are requested. Eventually, the coins are released for distribution. They leave the mint. They travel through the financial system. They reach banks, then businesses, then vending machines, cash registers, and parking meters. And eventually, they end up in someone's pocket. A coin that might have traveled thousands of miles began its life as part of a gigantic roll of metal. It was into a blank, heated to hundreds of degrees, chemically cleaned, pressed into shape, struck with roughly 100 tons of force, inspected, counted, packaged, and finally released into circulation, all for something that most people will barely notice when they pull it from their pocket. And perhaps that's the most fascinating part. A quarter looks simple. It's small, it's familiar, it's something we see every day. But behind that small piece of metal is an enormous industrial operation involving precision machinery, extreme temperatures, controlled chemistry, engineering, and thousands of individual decisions. The next time you hold a quarter in your hand, take a closer look. Because you're not just holding 25 cents, you're holding the final product of one of the most fascinating manufacturing processes in the world. If you want to see how copper itself is produced, we've left the link in the description and in the first pinned comment. And if you enjoyed this journey inside America's money factory, leave a like, share this video with someone who would find it fascinating, and subscribe to Source Code with notifications turned on. What should we explore next? Let us know in the comments. And until the next one, keep looking beneath the surface.